Alright, so let's go into our first of our four measures of dispersion, the range. So what is the range? Well, we can use the range for grouped ordinal and also ungrouped interval ratio variables. And although I mentioned at the beginning that we can really only use these for ungrouped interval ratio variables, notice how in here we can talk about and we can use grouped ordinal variables. And we'll talk about how we can really only use those for some types of variables. And really the range is just a difference in the value between the highest maximum number and the lowest or the minimum number. And the bigger this number, the bigger the range, indicates that there is more dispersion. So this is simply the notation for this. The range equals x sub max minus x sub min, where x is individual score. So the highest individual score minus the lowest individual score. But I want you to think about our Wilt Chamberlain example from last chapter. 20,000 sexual partners. Do you think that if we had Wilt Chamberlain and our virgin in there, our range would be what? 20,000 sexual partners. So the thing about the range is that it can be very misleading when you have outliers. Again, outliers are unusually high or low scores that can really throw off your mean. And in this case, we can also say that it throws off your range. So here's an example of how we calculate the range. Here are four students, Sarah, Stephen, Stephanie, and Adam. And here are their scores on the exam. Go ahead and see if we can calculate the range of these four students. Go ahead and pause and take a moment. Go ahead and return when you think you've got your answer. Alright, so calculating the range is simply the max minus the min. So we see the highest score is a 97 and the lowest score is a 50, so our range is simply 47. Nice, simple, easy calculation. Highest score minus the lowest score. Interquartile range, the second of our four measures of dispersion. So the interquartile range is just like the range, but it's not the range of the highest and lowest. It's the range between the 75th and the 25th percentiles. Remember percentiles? I used that word when we were talking about cumulative percent. Well, we're also going to talk about how we can calculate this interquartile range, because one of the nice things about the interquartile range is that it takes into consideration outliers. It really describes the middle class of a distribution. So think about this. We have our entire range of scores all the way from our lowest score all the way to the left to our highest score all the way to the right. It contains 0% all the way to 100% of all of our cases. Well, we know we have outliers, and those outliers are going to be either the highest ones or the lowest ones. And so if we have the outliers, those outliers are going to fall where on these diagrams? They're going to fall towards the ends, right? They're going to fall on this lower 25th percent and this higher 25th percent. And so the interquartile range, what this measures is the middle class, the middle 50% of the distribution. So one of the nice things, again, with the interquartile range is it takes into consideration outliers. Interquartile range is equal to Q3, also known as the third quartile, also known as the 75th percentile, minus Q1, also known as quartile 1, also known as the 25th percentile. So let's see, how do we calculate the interquartile range? Knowing that the interquartile range, also known as IQR, equals Q3 minus Q1. Finding the interquartile range. Here we have a set of 10 numbers. And we put them in order already, from lowest to highest. So notice that is one step that you want to do already when you're working with the interquartile range. Take your series of numbers and order them from lowest to highest. So the first step of finding the interquartile range is finding the median. So how do we find the median? Well, we first need to find what the midpoint is. We see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Midpoint formula, 10 plus 1, 11 divided by 2 is 5.5. So if we count to the 5.5th position to give us the position between 70 and 72, because we fell in between two numbers, we take the average of these two numbers, 70 plus 72, divided by 2 to finally give us our median, which is 71. So now that we've found the median, we now know that we have a lower half and we have an upper half. And that lower half consists of 62, 63, 64, 64, and 70. And the upper half consists of 72, 76, 77, 81, and 81. Notice that our median is not included in any of these lower or upper halves, and that every single number in our data set is included in the lower or the upper half. So now that we've identified our lower and upper halves, we then need to find the midpoint of each of those lower and upper halves. So how do we find the midpoint? Same formula, n plus 1 over 2. And so we have on the lower half 5 plus 1 is 6 divided by 2 gives us our third position, which is going to give us Q1, the first quartile, also known as the 25th percentile. And we do the same thing for our upper half. We have 5 numbers plus 1, which is 6, divided by 2 gives us the third position. So we count 72, 76, 77, position 1, position 2, position 3, to give us Q3, also known as the 75th percentile. And so now we have Q1 and Q3. And what's the definition and what's the formula for interquartile range? The range between the 75th and the 25th percentile, or the range between Q3 and Q1, which then gives us the interquartile range of 13. So this is how we work through calculating the interquartile range when we have even set of numbers. Here we have 9 numbers. So I want you to find the median, find Q1, which is your 25th percentile, your Q3, which is your 75th percentile, and then the interquartile range. See if you can figure this one out. A little hint. Remember, when you've identified your lower and upper halves, you need to find the midpoint. Go ahead and pause the video, see if you can work through this one, and then play the video when you think you've got your answer for the interquartile range. Alright, so how'd you do? Hopefully you got an answer. This was a little tricky, so let's see if you got it. So remember, we had 10 numbers in the example above. Down here, we have 9 numbers. So when we have 9 numbers, which is an odd number, what happens when we figure out what our median is? Remember, our median is finding the middle observation, and the formula for the median is n plus 1 divided by 2. So in this case, we have 9 scores, plus 1 is 10, divide that by 2 gives us the 5th position. So we count out from the left, 63, 64, 64, 70, 72 gives us our 5th position. So that means 72 is our median. So then what did you do now as far as identifying which one is your lower and upper half? Well, one tricky thing when we have an odd number of scores is that when determining our lower and upper halves, we do not include the median in those numbers. So notice our lower half consists of 63, 64, 64, and 70. Only these 4 numbers. The upper half contained 76, 77, 81, and 81. These 4 numbers. The median in this case is not included in your lower and upper halves. You've used this number up, so you don't include it in determining your lower and upper halves. So now that we've identified our lower and upper halves, what do? Find the midpoint of those to get our Q1, 25th percentile, and get our Q3, 75th percentile. We have 4 scores in each of our halves, so 4 plus 1 is 5, divided by 2 is 2.5. So we go to the 2.5th position, 63, 64, between 64 and 64. So we have 2 numbers. We need to get the average of those 2 numbers to actually find Q1, which in this case is 64. And for our upper half, do the same thing. We end up getting the 2.5th position, which falls in between 77 and 81. So we've averaged those 2 numbers to give us a Q3, or 75th percentile, of 79. Now that we have Q3 and Q1, last step, calculating their interquartile range. 79 minus 64 gives us 15. So the trick here is making sure that you know when do you include the median and when do you not include the median. If you have an odd number of scores, like the bottom, you do not include the median in identifying your lower and upper halves. If you have an even set of numbers, like on the top example, your median is not one of your numbers, so you use all of your original scores to fill up and make your lower and upper halves. Finding the interquartile range in a frequency table. So do you remember what column we should be looking at for frequency tables in trying to determine the percentiles? Hopefully you said the cumulative percent column. And really, we're going to do the same thing like we did when we're trying to identify the median. We know that the median is which one? Q1, Q2, or Q3? Hopefully you said Q2. So we look at our frequency table, look down our cumulative percent, and look for the response that falls within the 50th percentile. And we see that 20, the age of 20, is at 61.5%. So 61.5% of this sample of 1,204 people are aged 20 years or younger. The reason that 20 years old is Q2, our median, is because 50 percentile falls within the 61.5. 19 and 18-year-olds only make up 42.8%. So we haven't crossed that threshold of 50% yet with our 19-year-olds. So when we have our 20-year-olds, we get 226 more people. We get 18.8% more people to add to that 42.8% of 18 and 19-year-olds. So 20-year-olds make up the median. See if you can identify Q1, the 25th percentile. Which age contains Q1? 19-year-olds. So 19-year-olds contain 42.8% of the population, which also includes 18-year-olds. So 18 and 19-year-olds make up 42.8. But again, only 18-year-olds make up 17.7% of this sample. We wanted to see which age group contains the 25th percentile, Q1. What about Q3, 75th percentile? Which age? There you go, 21-year-olds. So 18, 19, 20, and 21-year-olds make up 77% of this sample. So now that we've identified Q1, Q2, and Q3, we can simply calculate our interquartile range. Interquartile range, 21 minus 19 equals 2. So we have an interquartile range of 2. The middle 50% of these 1,204 students is 2, a range of 2 years. But what if I just asked you, what's the range of this entire sample? Well, highest and lowest, 58 years old minus 18-year-olds, 40. So look at that. Interquartile range and the range. Compare these two numbers. That's a big difference. 2-year difference compared to a 40-year difference. So hopefully you can see the difference between interquartile range and the range within one data set and how these two really can tell you something about the distribution of your sample.